So we are on YouTube now, so you can join me there. Thank you. Okay. Today we want to talk about a new lesson, more or less new lesson. And I don't know if I remember the name of it correctly. It is not mentioned in the book. If I remember it correctly, I think it is called Thales. It's a ancient Greek mathematician. So Thales Theorem or something like that. I'm not sure that this S is included in his name. Yes, I think so. It should be Thales Theorem. Yes. So if you see, they have written top triangle succession or something like this. Okay, but I think the better name is this Thales Theorem. And this is very simple. And it's very important, by the way. So if we have a triangle, ABC, okay, consider one of these sides, whichever you like, that's no problem. And then draw a line segment from a point here parallel to this one. So, for example, you choose one point, whatever you like. For example, this one, let me call it M. And I draw a line parallel to BC here. This will go and intersect, for example, this one is N. So what is my assumption? What I just know is that this line segment is parallel to BC. Okay, there are two things that I want you to know. This would then imply, of course, this is a question mark yet. You can write the length of AM divided by the length of MB. Yes? If I ask you, do you think that AM is equal to AN? You would say no. In general, they are not equal. And in general, MB is not equal to NC. But if I respect this rule that it is parallel to BC, then even though AM and MB are correspondingly different from AN and NC, but if I calculate this and I calculate this, they become equal. So even in the cases that AM is not equal to AN and MB is not equal to NC, but still this fraction is equal to this fraction, and it is possible. Yes, for example, 2/4 is equal to 1/2. But neither the numerators are equal nor the denominators. So it is possible to have two fractions equal without having the numerators and denominators the same. So this can happen here, but of course there is a big question mark. Why? This is not something trivial. How should we know that this is true? Okay, but before coming to see why this is true, I want to write another one, and then from that one I will show you that this is true. So another way of writing this ratio is this. Write AM again. Instead of dividing it by MB, divide it by the whole side AB, not MB, okay? And then do the same thing here, AN, and then divided by the whole AC, they become equal. And if you do this, you can write the third one. The third one is MN over BC. Okay? So I want you to know both of them, number 1 and number 2. This is, I think, written in the book. Yes. I don't know. So there are different names here. Forget about that. So there are two relations. Be careful. If you choose to write this portion to this portion, the only thing that you can write is this portion to that portion. You cannot write the third one. But if you decide to write AM to the whole AB, then you have to respect and write AN to the whole AC. In this scenario, you can still continue and write MN over the BC. These three will be equal. Okay. So let me start with number 2, and I ask you, why do you think number 2 is correct? Forget about number 1 a little bit now. Just concentrate on number 2. So why do you think number 2 is correct if MN is parallel to BC? Yes?
Because it's förhållande. I don't know how to say that in English.
So you, sooner or later you need to learn the words. What's that word?
Ratio, perhaps?
No. So why the ratios are the same? That's my question. I'm asking why the ratios are the same. How do we know that the ratios should be the same? It's not trivial. For example, if I do not draw this parallel, for example, if I just draw this something like this, if this is A, M, N, B, C, N, can I say AM over AB is equal to AN over AC? No. How do we know? The answer to that is no. The answer to this is yes. This is what we want to discover. Yes, do you want to say something, Robert?
Well, since the MM line is parallel to the BC line and you're drawing like in the middle, it technically creates a new triangle that's, I forgot the word.
Similar?
Yeah, similar to the original triangle.
Okay, but middle in mathematics means exactly the midpoint. So, yeah.
Well, somewhere in there.
Somewhere, yes. So this is, why? Can you tell me why? Why these are, yes, that's correct. So Robert is telling you that he thinks, but you need to justify your answer. You think that ABC, so let me write AMN, is similar. AMN is similar to ABC. So can you tell me why? Of course, you are telling the truth, but you need to justify it exactly. So what does this MN be parallel to BC has something to do with this similarity? So for similarity, I have one theorem, yes? The main theorem was 2 angles from one of them should be the same size of 2 angles from the. Can you tell me which angles here?
Well,
one of the angles is very clear. It's common to both of them. A. So A is not only the angle of the smaller triangle, but it is also the angle of the bigger triangle. So it is in common. So I would write, if I want to write it. So you see, these things that I am talking about is a scratch work, yes, thinking. So now I understand what's going on. So I would write angle A is equal to angle A, common to both. Okay, this is not enough. I need one more angle, and then that is exactly what you told me that this is related. But it is something in Math 1C we learned. Yes, these 2 angles have to be equal. Can you say why? Of course, these 2 angles are also the same, but I don't need more than. Exactly. So the parallel and transversal rules, these 2 lines are parallel. Do you remember? I told you in Math 1C, if I have 2 lines parallel, and I have a line which is transversal, cutting both, then acute angles are all equal, obtuse angles are all equal. Agree? This was the parallel and transverse rule. So this is, you need to apply it here. So exactly.
What was the rule called?
Parallel and transverse line. Yes. So here we would say that MN. So I would write that MN is parallel to BC. Why? Because you told me this is the case. Based on this, I am writing this. So these 2 are parallel, and I would write that AB is transverse. AB is the transverse here. Okay, so from these 2, I can conclude this angle. So if you don't mind, let me write it U and V here. So the angle U is equal to angle B. Okay, now based on, according to angle theorem, AA, yes, theorem, we can conclude that what we have this relation. The triangle AMN is similar to triangle ABC, yes? Now that I know that the triangles are similar, I know that the corresponding sides have the same ratios. That's the meaning of being parallel, yes? So now that I know that this triangle on top is similar to this triangle, then the ratio of this side AM, in principle, if you want, so you should imagine this in a scratch paper. So this is ABC. So bring this small triangle out and see it here. Yes, this becomes AMN. Now, do you agree? This is the same thing. If I bring it out from there, and then it is clear AM and AB are corresponding sides. So I would write that what I can conclude AM divided by AB is the same as AC. AN divided by AC is the same as MN divided by BC. Agree? But so be careful. Do not mix up these relations number 1 and 2. If you write this to the whole line, then you can write 3 of them. But if you decide to write AM over MB, you can write only AN over NC, but you cannot continue. You have to stop there. Yes? So is that understandable? Yes?
I don't know how you got MN to be parallel with BC.
No, I myself draw it parallel.
Yeah, you yourself drew it parallel, but how do you know that it's parallel?
No, I'm saying that if I draw it parallel, then this will happen.
Oh.
If they are not parallel,
yeah,
then it doesn't happen.
Then it doesn't work.
Yes? Yes?
I was a bit confused about the last part.
Why? I'm writing the ratio. When I know that the triangles are similar, it means that the ratios are the same. So if I divide this length by its corresponding length from this bigger one, it would be the same if I divide this by its corresponding one. It would be the same if I divide this by. That's the meaning of similarity.
I think I get it.
Okay, is that understandable now? Okay, yes?
Yeah, couldn't you, instead of taking the A angle, just take the, the parallel and transverse and the N angle?
Any two angles will work. Yeah. But when I have already something in common, I don't want to make trouble. Then I have to write it again. But when there's something, writing in common is easier to write this. So, and there is a big rule for that. Be lazy, okay? Okay, now let us ask you why this is correct then. This doesn't come from similarity immediately. Because in similarity, I have to divide this by the whole side. I cannot divide AM by just one part of this side. I have to divide the whole side by the whole side, yes, to write the ratio. But this is not in that form. This is not probably that much geometry, it's algebra. Okay, so it doesn't have anything to do with geometry here. So can you see that? I want you to tell me from here, how should I go to that number 1? So to understand that, let me give these things some names. So for example, let me give them some names. If I, from here to here, let me call it A. From here to here, let me call it B. From here to here, let me call it C. And from here to here, let me call it D. And if you want, let me call this length X, this length Y. Of course, I am a little bit deviating from my convention because usually I told you call this one A, but forget about this. I'm just calling these names. Okay, number 2, we know that number 2 is correct because I was able to show it for you. So what does it mean? It means that AM, which is from here to here, divided by AB. What is AB? From here to here consists of 2 parts. One part is A, the other part is B. So do you agree with me that instead of AB, from here to here, I can write A plus B. Do you agree?
Yep.
And then on the other one, AN over AC. AN is from here to here, so it is C. AC is from here to here, so it is C plus D. Yes? And then let us stop here. Of course, I can continue, but I don't need more than that. This is number 2. We know that we showed it is true. We showed that it is true, yes? This, if I ask you, do you believe in that? You will say yes. This is just a translation of this into this new language. But number 1, what I want to show? I want to show that AM divided by MB. I want to show that A divided by B is equal to C AN divided by NC. This I know based on similarity. This is still I don't know. This is still I don't know. Okay, can you tell me how should I show that? This is not geometry at all. It is algebra. I give you this. These are just some positive numbers. And I ask you, if this is true, show me this one is also true. That's a very nice thing. Don't give me this answer that I simplify this. You cannot simplify, yes, because they are not products. That's a sum. So now the question is that, how can I prove this? And this is not a problem in geometry, it's just algebra. So my question is that, if I give you this relation between 4 numbers, A and B, C and D, can you tell me how can I conclude that this simpler version is also true? So I mean, it is algebra. It means that you can throw the picture away. You don't need the picture anymore. You just need your algebra knowledge to be able to go from here to here. I'm not saying that this is true. I am saying that if this is true, show me that this is also true. Yes?
What do you call it? If you use that like trick that you say means and extremes.
Yeah,
if you
the product of extremes is equal to the product of means.
And then if you do that, I think you can cross some things out. Which
Exactly. So let us start from here. So from now on, I really use this freely. So remember that if you have 2 fractions equal, the product between these 2 should always be equal to the product of these 2. So from this expression, I conclude that A times C plus D is equal to C times A plus B. Yes? And then let me multiply A inside. It becomes AC plus AD, and this becomes CA plus CB. Yes? But can I eliminate something from both sides? Yes?
AC and CA.
They are the same because there is no difference whatsoever between AC and CA, so I can cancel them out. And what is left for me is AD, and if you don't mind, let me write BC to keep the order. It doesn't matter, of course. So it becomes AD equals to BC. And what I do, I divide both sides by something. So I divide both sides by CD. If AD is equal to BC, it is reasonable that if I divide the left-hand side by CD and do the same thing with the right-hand side, they are the same, yes? Because they were the same, I did the same thing to both sides, they remain the same. But why this is good? Because can I simplify this D with this D now? Because that's a product. I couldn't simplify before here, because that was not a product, yes? So I can simply divide, it becomes A over yeah, that's not a good division, sorry. It is not wrong, but I do not get that one exactly. So I need to divide by something else. So BD. I divide by BD. Sorry. That was not wrong. I get a true statement, but that is not exactly what I want here. So I divide by BD. So this one, D and D are simplified. On the right-hand side, B and B are simplified. And what is left for me is A over B on the left, and what is left for me is C over D on the right. So this is the proof. So that is complete mathematical proof of why this is correct. The first one, which I wrote it the second one, is coming from similarity and geometry's argument. And then when I wanted to prove the first one, I use this and then use algebra to be able to show that numbers are correct. Yes?
Why did you divide by BD?
Yeah, I want to reach, there is no why in these kinds of questions, because you remember I divided by CD, it was also correct, but I got something which is not this one. Then I realized it was wrong, so I changed my division, and then I realized that this D and this D are gone. It becomes A over B. A over B is the thing that I want. That's the only reason. I want to reach to the other side, yes? So I need to do something that takes me from one side to the other side. Okay, so let me do it. Let me write a summary. This I want you to memorize, especially for the next year that discrimination is coming in. Yes. So you need to remember this. So let me just draw this picture. Let me draw this picture here. So let me do, for example, here. This is M. This is N. This is A, this is B, and this is C. So let me call this one A, exactly like the notation in the book, C and D. So let me call this one M and N. So we know that so let me write it big one. If it's not always true, if MN is parallel to BC, then so it is important, yes? If MN is parallel to BC, then you can write two things. You can write A over B, but if you decide to write A over B, you have to, there is no other choice. You have to write C over D. And that is the end of the story, full stop. You cannot go further. But if you want to write A over the whole line, A plus B, then you can write C over C plus D. Here you can, if you want to, you can go for the third one. And the third one is M over N. Yes? So you see, first we learn why this is true. I try to prove whatever we can at this level. This is what we could show. After that, you need to learn how to use it. You need to send it to your memory, otherwise you will be in trouble. Okay, any questions here? If someone asks you how we prove that, you should be able to, for example, if some students from other school ask you, you need to be able to tell. This is based on geometrical argument, yes? Based on similarity of two triangles. But if someone asks, oh, sorry, number 2 was based on that. And then someone asks you why this is correct, you would say, because of this one in algebra, I was able to come back here. And in this algebra, I didn't need the third part. I just needed the first one and the second one. So I was able to use that. Is that understandable? So I think this is a good problem. It's a very simple and good problem. Let us solve that. So for example, let me write an example here. I just choose it exactly from the book so that I just draw the picture here. So this picture is given to you in the book. This is an example, not an exercise. It's just an example in the book. So, and then they have, oops. This is given to be parallel. MN is parallel, so it is 11, it is 9, it is given to be 5, here it is given to be y, and here it is x and 12, and everything is in centimeters. You are supposed to find x and y if MN is parallel to BC. Let me give them names. This is A, this is B, and this is C. We know that, you see I'm emphasizing here, we know that MN is parallel to BC. We want to find X, we want to find Y. These type of questions. you should be able to solve them very simply and easy. You see, I'm emphasizing this theorem has some condition to be true. The condition to be true is this parallelness of these two, yes? Yes, but it is very extremely simple. Yes, for finding y, which one do you prefer, this one or that one? Of course, both of them you can use, but you don't want to make trouble for yourself. If I want to find y, what should I write? I would say that because MN is parallel to BC, what can I conclude? I can conclude 11 over 5 is simply 9 over y. As simple as that. And then all of them are known except y, so I should be able in principle to find y. And then I will usually use this product of extremes is equal to the product of means. So this gives me that 11y is equal to 45. And then I am looking for y, so I divide by 11. And usually I prefer to keep exact values. So this is exact value centimeters. So now you have your y. But then you have an unknown on x on this line. It means that this is not enough for you because you need to involve the third one as well. So this means that you are not able to use this to calculate x. So you have to use this version. So this is something that very easily you understand. Yes?
No, probably it's the wrong class. Yes.
Yeah. Okay. So now here so what should I write? I go back to this. Okay, can you help me to write something? I want to make sure that you understand. What should I write if I want to find x?
X divided by 12.
Let me put x divided by 12 at the end. Okay.
Yeah,
So
exactly.
okay, and then what do you write?
11 divided by 5.
16. That is the
Yeah,
important
sorry.
because you need to write 11 plus 5.
Because it's
Yes, be careful. If I want to find this, I have to use this version. And in this version, you see the denominator is a plus b. So you have chosen to write x over 12. It's good. But you need to remember that you are not allowed to write 11 over 5. You have to write 11 on the whole line, which is 11 plus 5. Yes? Is that understandable? Okay, then what happens? This means that 11 over 16 is equal to x over 12. You can start multiplying, but I myself prefer to simplify. I multiply by 4 to make the number simpler. If you don't do that, it works, but you need to work 12 multiplied by 11. But if I multiply by 4, it becomes simpler. This becomes 4, this becomes 3. And then I do this multiplication. So what happens? 4 times x is equal to 11 times 3, which is 33. And then x becomes 33 over 4 centimeters. Yes? Yeah, I think it's a very, so you need to be careful. When you want to do something about these two, you have to use the second rule. If you want to, for the first one, you can use either the first rule or the second rule. For example, can I calculate y using the second rule? The answer is yes, but I am making the problem harder for myself. Yes, let us calculate. It's want to see that it works, but it is not very efficient. So if your point is to calculate these pieces, you can use either the first one or the second one, but of course the first one is simpler. But if the question is on this line or that line, then you have to use the second rule. The first rule is not useful. But for example, let me just open a scratch paper. Let us check. Can I calculate y using the second rule? The answer is yes. But how should I write it? I should write 11 over 16. You see, the problem is here now. What should I write on the right-hand side? Can you tell me? What? 9 over 9 plus y. Do you agree? So this is also correct. But then, of course, I need to solve a harder equation. But if I do, it will give me the same. Let us check. I multiply 11 here, it becomes 99. 11 times this one, it becomes 11y. And 9 times this is 144. Okay? And I move this one to the other side. What happens? 11y is equal to what? 45. And then what is y? 45 divided by 11. And that is exactly the same number there. But you see that I've made a little bit more problem for myself. But if it goes to this line, there is only one way, and then you have to use the second. Is that understandable? Okay. And there is very important rule. I don't know why this is missing here. Okay, I understand why it's missing. Because it's harder to understand. Okay. So I don't know, should I talk about this?
Do. Please do.
Because I know that this will be a little bit confusing for everyone. We talked about this a little bit in Math 1C. And so do you remember, for example, we say that P implies Q, and then sometimes we talk Q implies P, yes? This is a statement. If this is true, if the truth of this gives you the truth of this one, you say that P implies Q. This statement implies the other statement. But if you interchange these two, this is called the converse. This is the English name for that, not the inverse, be careful, or not the reverse. It is called the converse of that statement. So the converse means that I replace these two. For example, I would say that if two angles of a triangle are equal, then two sides are equal. Yes? Is that reasonable or not? So this is a true statement. But the converse tells you that if two sides are equal, then the two angles are equal, which is also correct in this context. Yes? So this and that are both correct. So this is why we write them with double-sided arrow. And we read it as P if and only if Q. It means that they are completely equivalent. It doesn't matter. So the good example is this. You see, if I give you x is equal to 2, can I conclude that x to the power of 3 is 8? If I give you x is 2, do you agree with me x to the power of 3 is 8 or not?
Yeah.
So this is a true statement. If this is true, this is also true. What is the converse? How do you read the converse?
You can't.
You can change them. It might be true or might be false. We don't know. But this is the converse. The converse tells you that if x to the 3 is 8, then x is 2. Is it true or false?
No, false.
This is also true.
It's partially true.
Yeah.
No, it is true. We are working in real numbers. Okay? We are working in real numbers, so that is true. If x to the power of 3 is 8, definitely x is 2. There is no other number. So I can write that mathematically, x equals to 2 is if and only x is equal to 2 if and only if x to the power of 3 is equal to 8. Okay, so it means that mathematically this condition and that condition are exactly the same. But which condition is simpler for our brain? X equals to 2 is simpler for us. So that is actually the whole goal of mathematics. The whole goal of mathematics is to discover true statements, equivalent statements, which are simpler for us to work with. Okay, so this is one of those theorems. So this is one statement whose converse is also true. But let me change this slightly. X is equal to 2. X to the power of 2 is 4. Do you agree that this is true as well?
Yes.
Yes, but
That is true.
the converse is not true. Because if x squared is 4, there is no guarantee that x is 2. Might be x is equal to minus 2. So even though this statement was true, its converse is not true. But still, you can read the converse. The converse is a false statement. If x squared is 4, then x is equal to 4. So is that understandable? Okay. Now, so it means that these two statements are not mathematically equivalent. And that is the root of false roots. I have talked about this. If you have forgotten, you go back and watch the videos. Now here, let me talk to you about something. This is what is not in the book. So that is just optional if you want to learn. Okay. So here, if I draw this picture for you.
Triangle.
Yeah, triangle. And then I do this. So there are two things that I want you to understand. So here, in the problem that is in the book, I told you that MN is parallel to BC and then I was able to show you that this would imply that AM over MB is equal to AN over NC. This we showed. Okay. Now, can you tell me the converse? Do you see that this has the same structure? This is a statement. This is also a statement. A statement means it means a sentence which is either true or false. So here I am assuming that this is true. I was able to show you that this is also true. But can you read me what is the converse? AM divided by MB is equal to AN divided by NC implies that MN is parallel to BC. Some students, especially novice students, will take this one also for granted. This is not generally true, I told you. You see, here, this was an implication whose converse was true, but here that was an implication whose converse was wrong. So because of implication is true, you cannot conclude automatically, okay, the converse is also true. The converse might be true or might be wrong. It was true here, it was wrong there. Okay, so now, if this is 100% correct, this still needs a question mark. Unless you can prove it yourself. Is that understandable? Yeah. So I'm just telling you, don't take this for granted. Because I was able to show this, automatically I can conclude this. No, it is not correct. But sometimes the converse is also correct. This is one of those, which is not discussed in the book. And this is very interesting. The interesting point is that if you just take a triangle and just randomly draw a line here, but instead of checking that they are parallel or not, by the way, checking these two lines are parallel is extremely hard. Why is that?
You tell me.
I'm asking you. Extremely hard job to do. Why?
Because you have to know that they'll never intersect.
Yeah, I might exaggerate it a little bit. You know, it's not extremely hard. There are different ways, but Rocco is completely right. Because might be our eyes cannot detect the deviation. If I continue this, for example, when I reach to Dolagatan, they will intersect here. It might happen. But then if that's the case, my eye will not be able to detect that. Yes?
Well, you need to know the K values to know if they're parallel.
Okay, but that's analytic geometry. The point is that then that's one way. That's actually a very good way to do that. So you can set up a triangle. You can set up a coordinate system and then use measuring tools to read the coordinates and then find the slope of that and the slope of that. And then but what I'm saying is that algebra is more stronger when it comes to precise calculations. So geometry, you need to draw the line to see if it works or not. But in algebra, you can measure or calculate. One way to see if they are parallel or not, it's very simple. Take your ruler and measure this, and measure this, and measure this, and measure this. And then divide this by that, divide this by that. If they are equal, they are parallel. So is that understandable? So it's an extremely powerful tool. But I haven't shown you why yet.
You just gave the evidence, or what?
No, that's evidence is physics or chemistry or science. It's not mathematics. Yes. So what I'm saying is that if you know that the ratio from up to here is equal to that, then even you can be 100% sure mathematically that they are parallel and they will never ever meet in the future. Yes. So it's powerful, but it is not easy to prove it for you. I don't know, should I go through it or not? But
what do you think?
Yeah, I would say that let us not go through it because it needs something called indirect proof, and that is logically hard. And they moved it to Math 5 later. So yeah, so let us keep it for that time. But remember that the converse is also true. The question mark is still remaining for you, but at least you have an extra piece of information. That extra piece of information is that the converse is also true. But if someone asks you why, might be you will not be able to say why. Okay? But it is good to know that. And now there is something interesting going on. There is something interesting going on. So what do you think? If I take the exact middle point of this, middle point, and find exact middle point of this, I don't know if that's correct. Anyway, and then you just simply connect two middle points. You see, this I find the exact midpoint and the exact midpoint, and I just put my ruler here and connect them. I want to tell me why this line becomes automatically parallel to this one. Yes?
Because it's that divided by that.
Exactly.
and
Exactly.
one.
I just want to ask you, the questions that I am asking is not necessarily hard. I just want to test your understanding. Yes. Because I am saying that, let me call this A. What can I call this one then? A. If I call this B, what can I call this one? B. And now let us divide A by A. What's the answer? 1. Let us divide B by B. What's the answer? So do you agree that A over A is equal to B over B?
Yeah.
So it means that according to the converse, these two lines has to be parallel. Okay, and one more thing. We can say that what is the length of this one and the length of this one, how they are related. Yes?
Isn't it like A divided by A plus A?
Yes, yes. Yeah, exactly the same rule. Now go back to the same theorem. A divided by the whole expression is equal to this M divided by N. Yes? But can you tell me what is this?
That's a half.
It's exactly, because A divided by 2A is 1/2. So it means that M over N is 1/2. So it's very nice. If you connect the middle of these two, the length of this is half of the length of the third one. So it automatically becomes like that. So if I just connect the middle point to the middle point, first, I was able to show, using, of course, this converse, if you take that for granted, that this line is parallel, but not only parallel, but the size of this is half of the size of that. Is that understandable? Yeah. So that's good to know about triangles. So, but this is not in the book. Okay. We have a little bit of time. We want to actually show an interesting problem now. It's not trivial at all. And this is included in the book. I don't know why they have given it a name. Yes, they have given it a bisector rule or something. Let me motivate you by this question. I have a triangle. And then I draw the angle bisector of this angle. It means that I draw a line, so if I can do it. So you need to divide this angle, for example, into two equal pieces. That is called the angle bisector, that line. So this line that I start from here, and I just go up to the intersection point with the opposite side. Wherever it is, I stop there. And I am assuming that I was able to do them exactly equal. So A1, if, again, a big if A1 is equal to E2, then I want to ask you some questions now. Okay? It's highly non-trivial question, so I don't think if we have enough space to show, hopefully it will work. Yes. So let me give you this number 5. Let me write something random here. 5. Everything in centimeters, for example. And then let me give you 8. And then I will ask you this. So it is highly non-trivial because there is no parallel going on. Yes? So this is called bisector, how do you pronounce it? Bisector or something like that. Yes? So, bisector rule or bisector theorem. Satsen, I think they should translate it. Rule is different. Satsen means theorem, I think. That's a translation. So, bisector, so it's very high, it's non-trivial, by the way. How do you calculate this? What I am doing, I have this angle, okay, and someone draw this line for me, which bisects this angle into exactly two equal pieces. And then I continue this line so that I find this intersection point. I give you the length of this side, I give you the length of this side, and I'm asking what is the length from B to D. Yes? Okay, I should also give you something extra.
Yeah.
So let me give you this one as well.
Because you have two angles.
Yes, let me give you this one as well. So for example, 5, 8, and then let us take it 12. So this is what we want to discover today. So I want you to be able to discover that if I give you these three sides, yes, and then you draw the angle bisector, it will intersect the opposite side into at some point. I want to find one of them. Of course, if I find one of them, the second one is trivial, yes, because the whole is 12. For example, if you get this is 3, the other one becomes 9. So finding one of them is hard. Finding the other one after finding the first one becomes simple. So this is not trivial at all. So let us understand how we can solve this problem. So you need to be creative. These kinds of creativity is very hard. Some parts of it comes from hard practice, and some part of it, I would say, is talent. Yeah, but that is a little bit rude to talk about talent in Sweden. Yes, but if you like it or
Everything
not.
is rude to talk about in Sweden.
It seems so. Okay, so how should we find this? But how this problem can be related to what we talked today? Yes, because there is no in the problem that I talked here. I had a parallel line, but here I do not have any parallel line. Yes?
You draw a parallel line.
Okay, so exactly. So let us see if I can draw it efficiently. But this is not easy to come to mind immediately. I don't know, have your book. So your book is actually doing it in a completely different way.
Really?
Okay, yes. But let us do it with my way, using the idea that we learned just now, okay? Because in the book, the way that they have done it is completely correct and nice, but it is disconnected from the first part of the lesson. But let us do it exactly as in the first part of the lesson. So I was a little bit careless to draw this picture so big, but hopefully it will work here. So don't forget, A1 and A2 are the same. So the idea is very strange. The person who actually was able to find this very old days, so it was very, he was very, or she was very clever, I don't know. So the point is that take this point and draw a line parallel to this, okay? So let me see if I can do it. See? Something like this. So at this stage, don't say why. Just listen to see what it works, because it is not clear why. The why becomes clear at the very end that you see it works. That's it. So then, and then continue this one, and then find the intersection point here. Okay, and let me call this one E. But now there are many things that you can help me. Okay, I ask you questions little by little, and then I want to wait for you. First of all, do you think that somehow the first part of the problem is connected somehow to this? Yes, in this problem, try to be creative. Yes, in the problem that I started with, I had a triangle from the beginning. I drew a line parallel to one of the sides, and then immediately I can write those ratios. Now, actually rotate it in this way. This is also the same story, yes? But now this is playing the role of this line, yes? And this line is playing the role of this line because they are parallel. I drew it myself. Is that understandable? So the idea is to think it the other way around, okay? But before going to that, let me ask you some questions. I want you to show it to me that IEB, should I tell you, okay, is an isosceles triangle. Why is that? So remember, I just drew, so let me point it, maybe it help you. This is parallel to this one. Let me put an arrow here and an arrow here. So you know that these two lines are parallel. You know that this angle and this angle are the same exactly. But my claim is that this triangle you see here is an isosceles triangle, and I want to see why. Can you tell me? Of course, my picture is not too bad. It's not precise, of course, but might be you should be able. So why is that? Isosceles means two sides are equal. Yeah. Can you see why? Anyone from home, actually? Yes? Isn't it clear? Yeah, it is a little bit technical, I agree. So let me help you. I'm explaining it. Might be we don't have time. We will finalize it next session. But let us see what happens. My claim for you is this angle. Let me call it alpha. Can you tell me why alpha and A1 are the same? They are exactly equal. Yes?
E1.
Parallel and transverse. Yes? I told you, do you remember in Math 1C, I told you remember this letter Z. Whenever you have letter Z or I don't know this variation N or I don't know upside down. Yes? So these angles are always the same if they are parallel. Yes? And now do you agree that this is I don't know, this is whatever, this is not N, this is upside, I don't know, flipped N. Yes, is that understandable? So this alpha and A1 are equal. Do you agree? Based on what we learned. Okay, now let me ask you one more question. Angle beta is equal to A2. Why? Yes?
It's because the sum of alpha and beta should plus the other angle should become like beta.
Okay, but then? But I want to show that this one is equal to A2. The same story. The same. Yes, you see these two lines are parallel. This line is this line. And this line is that line. And then let me draw this line. Yes? So where is beta? Beta is here. Do you agree? And where is A2? A2 is here. So they are equal. Exactly because of the same theorem. Yes? Parallel and transverse. So beta is equal to A2. Yes?
That's if it's parallel.
Yes. But what is, they are parallel. I drew it parallel. You are killing me. Yes, I drew this line parallel. Okay. And then A1 is equal to A2. Do you agree? And now Hussein says that if they are equal. Yes, they are equal. Yes. Under these conditions, what can I conclude? I knew from the beginning A1 was equal to A2. By this way of construction, I realized alpha should be equal to A1. I realized beta should be equal to A2. What can I logically conclude from these three equalities? Yes?
Alpha equals beta.
Alpha is equal to beta, yes? Because alpha is equal to this, beta is equal to this, these two are equal, so alpha is equal to beta. And if alpha is equal to beta, this means that this line is equal to this line. Yes? So if this is 5 centimeters, what is from here to here then? 5 centimeters. And now everything is done. We are done actually. Can you see how? There's one step left and then we are done.
Give me a minute.
You still want to find x. Exactly. You need to see it in this way, yes?
Yeah.
Yes? So can you tell me what should I write now? This one is parallel to that one, so I can use the Thales Theorem, yes? What can I write? I can write this expression divided by this expression. So this is 12 minus x.
Yeah.
So 12 minus x divided by x is equal to what? Tell me.
It's equal to 8 divided by 30.
No, because this is part by part. This part by this part is equal to this part by that part. Yes? So it becomes 8 over 5. And what is left here for me? Just x. So you solve an equation. So what does it mean? It means that 8 times x is equal to 5 times this, which is 60 minus 5x.
Yeah, 15 over 10.
And I move it to the right hand side, it becomes 13x is equal to 60, and then x becomes
60 over 13.
centimeters.
Yep.
So you see, geometry is actually a very, very powerful tool in your hand to train your brain for thinking. And it is not hard. It's not easy at all. Not easy at all. Geometry, plain geometry, could be extremely hard. It's not easy to find it. So you see, this part of the picture was completely absent in the original picture itself. So the person who actually solved the problem in that way was creative enough to draw these pictures and realize, connect these two items and solve the problem. So now, if you are skillful in algebra, you can find the formula for that. In algebra, instead of giving you numbers, I give you letters, and then you do exactly the same scenario algebraically and find the formula for this. And if you find a formula, it means that you can use your formula all over again, but not in the exam, of course, because in the exam I want you to see that you know the rule. Okay, so now I think it would be good if we stop here. Let me see how the book has done it. Let me see the answer in the book.
I think it would be good if you showed us that version also.
Yeah, but I don't know this version. I need to read it.
Sure. Take your time.
I just want to know, earlier you said if you take the middle of the triangle, then you put a line to it, you could divide it, right? You said, like, let's say 5, you divide it by 2, and you have to.
No, it is not divided by 2. That was exactly the same.
Yeah, not about the question. I'm saying, like, here, you put a line in the middle instead. Like that picture right there, like the blue one.
Okay.
And then try to solve it from there.
No, which is not possible. If you can, that's a new way.
Hur börjar Hussein?
Yeah.
Eller förlåt, HC.
So, Hussein, you calculate whatever you like. You need to calculate what is demanded in the problem. I want to calculate this x, not the middle one.
Yeah.
If I want to calculate the x when d is in the middle, it is 6. It doesn't need calculation, yes. But if it is a bisector, so let me see how they are solving the problem.
Alltså, 8. Vrider huvudet så. Då har du den sidan, 8, som är över den andra sidan. Och det var ena formen.
Okay, so I think that because they are tilted the picture a little bit, so we have a little bit of time. So let me see that if I can see you the version of this book. So in the book, I think they want to do something like this, if I understood it correctly. So let us give you the same picture.
Det är fel vinkel än det här, men det är så det är.
So this is A2, this is A1, B, and then this is D, this is X, and this is C. And assume that this is the whole, so this is the whole. So what they are doing, they are taking another side and drawing something parallel to the other one.
To the other side.
So yes, I think they are doing like this, if I understood it correctly.
They just make a number.
So they are, because no, there is no line parallel to this one. So they have taken this probably from here and they drew something parallel to this side, not to the bisector. Okay, so let me, if I understand it correctly, so let me first think myself, and then if this works, then I will tell you. So what they are doing, they are taking this line parallel to this one from here. Okay, and then so this one is parallel to this one. They take this point and draw this line parallel to this one, and I think they will continue this bisector. Yes, they will continue this bisector until they have this intersection point. So you see, they are also doing something parallel, but I drew the parallel line parallel to the bisector, but they have chosen a point, except that point, either this one or that one, it doesn't matter. And then you draw a parallel line with this side, not with the bisector. And then you continue the bisector. Here, I drew a line parallel to the bisector. I continued the side, but they are drawing a line parallel to the side, but they are continuing the bisector. Okay, so I think the idea is not that hard now. So here, this number is 5, this number is 8, okay? And this is x still. But I hope that now they prove that this is, so let us concentrate here. So do you agree that if these two lines are parallel, and if this is the transversal, if this is A2, I call this one alpha, alpha is equal to A2. Do you agree?
Yeah.
Because these two lines are parallel and this is bisected, this is the transversal. So this means that alpha is equal to A2. Okay? But now, let us see the problem from another perspective. Okay, and then what happens? It is much simpler, by the way. This alpha is also equal to A1. Why? Because A2 and A1 are the same. Alpha is equal to A2. A2 is equal to A1. So alpha and A1 are the same. So it means that this bigger triangle here, this whole triangle that I am just hatching right now, is isosceles. Yes? So which it means that B to E is equal to 5. Yes? So BE is equal to 5. Do you agree? This triangle is an isosceles triangle. Okay. And now this triangle and this smaller triangle are similar. Why? Why they are similar?
They share two angles.
Okay, which angles?
Alpha and
alpha is equal to A2.
Yeah.
And this angle here is equal to this angle there. Okay, so these two are similar now. They are not using Thales theorem. They are using similarity now. So this one and this one are similar. So the ratio between BD, yes, the ratio between BD and DC is equal to the ratio of BD and the ratio of 5 to 8. Yes, so this is what we get. Unfortunately, BD, no, that's exactly true. BD is Rx, DC is 12.
No, this is
12 minus x, thank you. And then 5 over 8.
Which is the same.
That is the same equation, yes. I got it there, but it is reversed. Yes? So you see that this is another way. It was different. The structure was still you need a parallel line, but I did the parallel line in this way, and I used Thales theorem. They did the parallel line in this way, but they used similarity. Of course, I didn't know this method before, but when I read it, I see that this is also very nice.
And they talk about Thales theorem in the book.
No, they don't mention it, but they call it, I don't know, they have given it different names. Yes.
But it's still the same formula.
Yeah, okay. So we learned 3 formulas today. 2 versions for the Thales theorem and 1 for the bisector. But I haven't finished bisector yet. I will continue next time.
There's like 10 formulas for this test.
I don't remember.
Well, we have a bunch for.
So let me just stop this.
Geometry.
So thank you very much. I stopped this meeting. Okay, now we're stopped.
Yeah, there's a bunch.